these are questions that kind of the one that you just did a learning goal on, and these ones you really want to recognize it, know how to solve it. You got to know what to let X represent. You got to know how to set it up. And then they're kind of all very similar to each other. All these questions are very similar. Does anybody remember? What do you think we should start with? A let statement, maybe even in this case before that. Yeah, draw a diagram. Let's draw this out. So we'll read it first. Rectangular pool is 8 meters by 4 meters. A cement sidewalk of uniform width. Right away when it says that, I'm like, oh, I know what kind of question this is. It's one of these border questions. Is to be constructed around the pool. Determine the width of the sidewalk strip. If the area of the sidewalk surface is to double the pool. So notice that it always gives you some information about the areas. It gives us, in this case, the dimensions of the inside part, and we're supposed to find the width. And sometimes it could say the dimensions of the sidewalk or something. Like it might say something different, but, oh, thank you. Okay. So those are the sort of important parts of this question. So here we go. Here, I'm going to draw the pool first and label it. So this is 8 meters, and this is 4 meters. And then it says the sidewalk is to be constructed around the pool, and it's going to be uniform width. So I'm going to draw this as best as I can, but it doesn't have to be drawn super to scale. Whoa. Ah. But what's important is that I understand that the width is the same on all sides. And that's what it's asking us to find. So it's asking us to find this width. And in almost all cases, the thing you're being asked to find is the thing that you let X represent. And in this case, that is what we want to do. We want to let X represent the width of the sidewalk. And if you didn't start with that, if you said X and Y were the dimensions of the outside, you're not going to be able to solve this problem. Okay? So you have to get the right thing for X. Anybody remember what's next? There's two things that we have to do before we can even write our equation that we're going to solve. Well, that's going to be the thing we do in the end, because that's the whole point. Yeah. What's going to make up our equation? So I'm given 4 and 8. Here's my X. Why do I need that information? What can I do with it? Okay, so one of the two things we're going to do is work with the areas. So we're going to do it like this. The area of the pool is length times width because it's a rectangle. So it's 4 times 8, which is 32. And the area of the sidewalk is twice, double the pool. So 2 times the area of the pool, which is 2 times 32, which is 64. Good? What's the other thing that we have to do? So we've got the area of the sidewalk, but I don't have dimensions for the sidewalk. So the other thing we have to do is find the dimensions of the sidewalk. How am I going to do that? In other words, what is this distance, and what is this distance? We don't know them exactly. If I knew them exactly, the question would be done. So we have to write an expression for them. How do you do that? So this part's going to be how long? What? That inside part is 8. And what is this part going to be, and this part going to be? 4 is across the side. X. So what happens if I add those 3 parts together to go all the way? Very good. 8 plus 2x, or 2x plus 8, and 4 plus 2x, or 2x plus 4 for the top. And again, that's going to look basically the same every single time. Okay? Now we can set up our formula, but be careful, what area am I going to use? When I multiply those together, when I do 2x plus 4 times 2x plus 8 equals the area, what area am I using? Just look for a minute. Think about area. Think about what it means. 2x plus 4 is this dimension. That times that will give me this whole thing. The entire area inside the square. How would you describe that whole area? In terms of what we've done here. Is it just the area of sidewalk? That would just be this.
Oh, so it would just be area of pool and area of sidewalk.
We need the total area. We need both, right? When I multiply these dimensions, it's going to give me the area of both of these added together. So the last thing of this is I want to do area total is the area of the pool plus the area of the sidewalk, which is 32 plus 64, which is 96 in this case, and that's what I get here. Now listen carefully. Not every single question works that way. It's not always doubled. Some questions are worded in slightly different ways or gives you slightly different information. So you do have to read the question carefully and think, do I take the areas and add them together? Or I could imagine a situation where you subtract one area from the other or something along those lines. Okay, so make sure that that part makes sense for the question that you're doing. But usually we find 2 areas and add them together. That's usually the case. Now what are we going to do? Expand, simplify, move it all one side, and solve however we're going to solve. Factor if you can, or quadratic formula. 2x times 2x is 4x squared. 2x times 8, 16x. 4 times 2x is 8x. 4 times 8 is 32. (32 minus 96 is negative 64. What do you think I should do? Ooh, it might be. I like that thinking. Because this is a perfect square and this is a perfect square, so it might be something like that. Or I could check or you might have meant check the discriminant to see if you can factor. What else can I do? There is a common factor. I would do that first. I think I can divide a 4 out, can't I? plus 6x minus 16. And now do b squared minus 4ac, and I think you'll find that this is factorable. And just like yesterday, we get to the end after we've done all the solving, and we're like, wait a minute, what were we even doing? What were we even talking about? Right? And I go back up and I think, okay, so I found x is -8 and x is 2. I go back up and I say, what was this question about? Determine the width of the sidewalk. Let x represent the width of the sidewalk. I found x. So I think we're done, except I just have one last little thing to do.
You would sub the 2 into the original question.
I don't know that I have to in this case. If it asks for the dimensions, I would have to go find the dimensions. It just asks for the width of the sidewalk, which is x. So I think that part's done. I'm going to do a therefore statement. What am I going to say in my therefore statement? What do you think about these answers? Like, what is the answer to our question? Yeah, we can't have a -8 meter wide sidewalk. I don't know what that would look like. Okay, so this one's inadmissible. And we do our therefore statement. Therefore, the sidewalk is, were we talking meters? Yeah, 2 meters wide. Any questions about that? All right. I want you to see, so this one's going to be very similar. What are the dimensions of the new picture? So it's asking a slightly different question. But it's going to be a similar question. So I want you to try to draw the sketch, the diagram that we need, and do your let statement. And then we'll see how that goes, and then we'll take it up together. So give that a try to start. So I got this far. So now, if you got this far, again, we know that we need to do two things. We need to do something about the area, and we need to do something about the dimensions. Which one do you want to do first? Which one can we do?
Dimensions.
The dimensions are exactly the same as the last question, so that's easy to do. So what do you think they are? Noor, do you know what they are? What were they in the last one? How did we do it in the last one? Yeah. Like watch. Just remember, we did 8 plus x here and x here, so it was 2x plus 8 or 8 plus 2x. Good, and? Very good. 2x plus 18 there, and 2x plus 12 there. That part was the same. The area part is a little bit different. But we will find the area of the picture first, so let's do that. The area of the picture is 12 times 18. I got 216 for that. But then it says the picture is going to be enlarged by 30% of the original area. So to find the total area, we're just going to increase it by 30%. Does anybody, we don't have to find the area of the strip first. Does anybody know how to increase something by 30%? Yeah, Ellie. We are going to multiply. You don't just add 30 or you don't just add 0.3, right? You don't just add a percent. What are we going to multiply by? 0.30. There's two ways of doing it. I'll show you the fast way in a second. Off to the side here, I'm going to show you this way. If I took 216 times 0.3, which is 30% as a decimal, I'd get 64.8, but that's not the total area because that's not an increase in size. What would I do with that? No, I don't need to multiply that by 100.
Can't you just divide 216 by 0.30?
I'm going to add that number to the first amount. So then my area would be 216 plus 64.8. 64.8 is 30% of 216. So I would add that to 216 to get the total. But there is an easier way. And it's I take the area of the picture, and this is a really useful life skill, folks. And instead of multiplying by 0.3, I multiply by 1.3. Let's see if we get the same answer. So this was 280.8. And if I multiply, you multiply 216 times 1.3 and tell me if you get the same thing. Yep, 280.8. That's a little bit easier, saves you a step. These are the only ways of doing it that you can't, don't try anything else. Okay? Be careful of that. Finding an increase, a percentage increase of something or percentage decrease is really useful. Because like you'll know if the cost of something that you're going to buy has been increased by 10%, you'll know what it is. Or like if it's on sale for 15%, you'll know how to find the sale price, like all those kinds of things. It's a useful thing to be able to do. Okay, and now we have everything that we need. Remember we had 2x plus 12 and 2x plus 18, and that's equal to 280.8, which is the new total area. I want you to try solving that. So I expanded and simplified and I got that. What are we going to do next? Yeah. And I checked it actually. And I got, so b squared minus 4ac equals 4,636.8. And because of this decimal, you know, I got a decimal there. And so I might have just used the quadratic formula for this one because of the decimal. It's possible that that could be a perfect square. Decimals can be perfect squares. This one isn't. When you take the square root of that, you get something, some nasty decimal. But sometimes when we have decimals in the question, we just go straight to quadratic formula. So we'll do that. So I got 1.01 and 16.01. Negative 16.01, sorry. So what are we going to do next? As soon as you get your answers, you got your x equals answers. You want to go back and read the question. Sarah, what do you think? Like, what are we talking about here? Remember, there was a question yesterday where the negative one was the one we wanted. But often one of the answers we don't want. It's inadmissible. Oh, right. X is the width of the strip. You can't have a negative width. So Sarah's exactly right. This one's inadmissible. By the way, you have to say that. You have to say that. Cross one out. Cross it out lightly and say it's inadmissible as part of your solution. Otherwise, it looks like one solution just kind of disappeared. And this question says, what are the dimensions? So we aren't done yet. We still have to find them, right? So I'm going to come off the side here, find the dimensions. X is 1.01. And my dimensions were 2x plus 12 and 2x plus 18. So my width will be 2 times 1.01 plus 12, and my length will be 2 times 1.01 plus 18. And it says to round to one decimal place, so this rounds to 14.0 and this rounds to 20.0. Centimeters. When you're rounding to one decimal place, even if the decimal is a 0, it's necessary, right?